equations. And you should, at this point, be able to take any element up there, at least up through 50, and give the long way and the short way. Now, when you do that, that takes care of all the electrons that that substance has, all of them. Okay, now we're going to talk about quantum numbers, and there are 4 of them. And when you get quantum numbers, and here's the important difference, each electron has its own 4 quantum numbers. It's a code. It's really its address. And so this is just another approach. Actually, this came from some very fancy mathematics, is how they came up with this, but I'm making it as simple and concrete as I can. Let's start with our first quantum number. Okay. First quantum number in this address. We designate it with a capital N. And what it stands for, major energy level. And remember how chemists are. They talk several different ways. They may say major energy shell or major energy level. They may say major, they may say principal. And so we've got several renditions. So on test day, I'll try to put up all the translations I can think of, because people use those interchangeably and they don't realize how problematic that is for a student. So the major energy level, we already know that. We've been using N's before. And what this tells you, and what values we can have. So here's the code. I've got an electron, its address starts out as N is 1. Where is that guy? First major energy level. See, it's a shorthand talk. I've got an electron. This electron I'm describing, N is 2. Where does he live? Second major energy level. Okay, so you already know about N, and you know about major energy level. It's just a different way of speaking. Now let's look at the second. Second quantum number. Okay, they designate it with the letter L. That lowercase l. And what that's going to tell us in code is the sublevel. Now, what are the allowable values? Let me give it to you in math talk, and then I'll translate back to what you already know about. What values can it take on? It starts at 0, unlike this one that always starts at 1. 0, 1, 2, 3, and it can go up to n minus 1. Now again, that's confusing at first because that's mathematical talk. Let me fix up a table. This is the old talk, when we had sub-levels. S, P, D, F, and so forth. Those were the names. And when we were doing the 1S2, 2S2, I said, think of S as a name for the sub-level. It's like Susie or Sally or whatever. It's a name. Okay, so this is the old talk that we are used to. This is the new talk. It's a code. If we're in an S sub-level, we say in code, L is 0. Now what's going to help us remember that? What's the shape of an S orbital? It's a sphere. Like so. S. S. If I tried to draw a sphere on the board, I would draw a circle. But that's a 0. Okay, so it's code. When you were young, did you ever come up with a code with your friends? Like, you wanted to say dirty words and you didn't want your mother or your teacher to understand what you were saying? It was so cool. Like, if you wanted to say A and spell a word, you'd say the number 1. If you wanted a B in your word, you'd say the number 2. Okay, so you would spell out words and you'd walk in recess and go, oh, 862. Yeah, I hope that didn't spell anything. I just made that up on the spot. But didn't you have codes like that that you thought only you and your buddies knew about? This is chemical code. So we are working for the CIA. So if we want to say we're in an S sub level, we're going to say L is 0. Then it's 1, 2, 3, and it just builds up luckily in numerical order in full whole numbers and no negative numbers here. So if I've got part of an address. Here's the first two parts of my address. Okay, what I want you to do, this is the new quantum language talk. I want you to translate. Remember, this is for one electron. Where is this guy?
2p.
Okay, I'm hearing 2s and I'm hearing 2p. Which is it going to be?
2p.
2p. That translates, that guy lives on the second major energy level in a p orbital.
So then you have it like lower down. Are we like trying to figure out like which actual
Where it lives,
element?
where that one electron lives, okay? It's his address. And every electron in your atom has its own 4 quantum numbers or its own address, which means that, back last Tuesday, I'd say, let's go do carbon. Well, on Tuesday, you would have said 1s2, 2s2, 2p, how many? Was anybody listening? I want to do carbon. 1s2, 2s2, 2p, 2. That takes care of all the electrons in carbon. That tells you something. Now, if it's an inappropriate question for me to say, do the quantum numbers for carbon unless I'm really mean. Because you've got 6 electrons. Each electron has its own 4 quantum numbers.
So the first one would be like, so far what we know would be like 1, 1, and then
1, 0. Yeah, 1, 0. Yeah, exactly, exactly. So what I want you to do is, I give you these 2, and you can tell me where that guy lives. All right? Now, everybody okay with the code here? What about this crazy math stuff? What are the allowable values? 0 up through n minus 1. Okay, if n is 2, L can be 0, can't it? Because you have a 2s sublevel. L can be 1, because you got a 2p sublevel exists. Can L be 2 here? No, because if I said n is 2, L is 2, what does that translate as? 2D, and it doesn't exist. Now, you already know what exists. You know, if you're on a second major energy level, you got an S and you got a P, end of story. This is just a mathematical way to state that same thing, what exists. Because you can start with 0 each time and build up to n minus 1. Well, if n is 2, n minus 1 is 1, that's the highest one you can have. Now, if that went whoosh, no big deal. Because you already know, I'm on a second major energy level, what could possibly be there as sublevels, an S and a P, no more. Okay, let's move on to the third quantum number. Everybody holding up okay? Okay, you don't quite look like believers yet. Let me take one more. N is 3. Remember its code. N is 3. L is 2. Where am I? 3D. See, we're translating. You're on the third major level. L is 2. Look back over here and cheat. We're in the 3D. And we know that exists. Okay, what if I make a mistake? What's my mistake? There's no 3F. Can't be. Okay, let's move on. You're doing well. Okay, third. Third quantum number. By the way, this one is the most difficult. So when we get it, we've been to the mountaintop, and then it's a downhill slide to pick up the fourth one. So, okay, third quantum number. We designate it M sub L. Okay? M sub L, that means the letter M with a subscript of the L. And what does it tell us about orientation in space? M sub L. And what are the allowable values? Now this is math talk once again. It can be minus L, using integers only, up to 0, up to plus L. Now I know that doesn't make any sense at all right now, but hang in, don't tune me out yet. When we're talking about orientation in space, let me go back to my models. Also, does anybody have their book handy that had the pictures? Somebody, yeah, Emily, be looking where those pictures of orbitals are while I use my models.